Alright, in this video, first objective is to find Newton's second law of motion, and 2, manipulate Newton's second law of motion to describe the change in motion of any object. First, we'll start off with what the second law says. Second law states the acceleration of an object depends on the mass of the object and the amount of force applied. Now let's revisit what acceleration, mass, and force mean. Remember, force is measured in newtons, okay, capital N. A force is a push or a pull. Our mass, measured in kilograms, capital K, lowercase g, is the amount of matter an object has. Every object has a mass. It's the amount of space it takes up. That's what it talks about, the amount of matter. And acceleration, meters per second. Meters, okay, our SI unit is meters per second squared. And it's a change in an object's velocity. The rate at which the acceleration changes, the rate at which velocity changes from start to finish. Newton's second law is primarily defined as force equals mass times acceleration. So if we're taking a look at that formula, we have a mass of 10 kilograms times an acceleration of 5 meters per second squared. Okay, so this 10 kilogram mass is traveling at 5 meters per second squared. Every second goes by 5 meters. So what we do to figure out the amount of force needed to make this happen, just plug it into the formula. We get 10 kilograms times 5 meters per second squared. Our force equals 50 newtons. Therefore, 50 newtons needs to be applied to a 10 kilogram mass to make it move 5 meters per second squared. That's one way to manipulate the formula. Another way to manipulate the formula, to solve for acceleration, all we do is we put acceleration over to the side and we get force divided by mass if we're solving for acceleration. So again, we have a 10 kilogram mass. We're applying a force of 50 newtons to the right. All we need to do is put it into the formula. Acceleration equals 50 newtons, our force, divided by our mass, 10 kilograms. So our acceleration is 5 meters per second squared. Again, a second way of manipulating the formula, depending on whether we're solving for acceleration or we're solving for force. So now what I want you to do is you try applying it. Your first problem is, what is the net force on a 2 kilogram skateboard accelerating at a rate of 2 meters per second? Now remember, net force is the total force acting on an object. Acceleration, the rate at which velocity changes. And rate is just the fancy word for speed. Just make sure we're still on the same terms. After you solve this problem, go on to the second part here. If the mass of the skateboard doubled, right, so this is increasing twofold, so that's going to be 4 kilograms. The net force on it remained constant. We're not changing the amount of force. What would happen to the acceleration of the skateboard? Again, press rewind, fast forward, either way, so you can try solving these on your own. That's Newton's second law of motion. Force equals mass times acceleration.